Okay, we have one final presentation to give, and it's Jay Evans, who also works with us. And while he's coming up here, I'd just like to make a point which we've made a number of times in different meetings with our colleagues. A number of the presentations that have been made today have been by PhD students, and there's going to be more tomorrow. This is the sort of investment that must be made for the future. And I know you understand that, but it's something that needs to be really built into these GCF projects and other projects, because you know, these people are the future.
Thanks, Jeremy, and thanks for coming. What time is it? 6:30 on day 3. Thanks for still being here. It's a good effort. And thanks for everyone for being so quick and letting me take till what, 7 o'clock do I have now? That's great. All right. Well, that was all pretty interesting and quite heavy. You can probably think of this as a bit of a warm down before dinner later. I'm going to talk about inferred ecological benefits from savanna burning. A lot of this stuff, while the impetus for it all is to abate emissions and obviously work towards you know, mitigating climate change, before it all came about in Northern Australia, there was a big concern about the impact on the environment from unmanaged fire regimes. And that sort of predates the start of all this sort of stuff, and actually underlined a lot of the reasoning and the impetus for building that stuff. And so to take that sort of stuff a bit forward, now we can look at how these changed fire regimes as a result of this work are having beneficial results for the environment. So I'll go here. That looks good. All right, so I'll talk about a couple of case study regions in North Australia and the top end of North Australia. Australia's premier national park, Kakadu, savanna environment, and the West Arnhem Fire Abatement Project, which is really the premier savanna burning project, and was the blueprint project for building the savanna burning methods. And there's mouse work there. Oh, yeah. So, and they're based in the top end of the Northern Territory, and sort of you can see there the centralised over this region, the Arnhem Plateau, and that's a region of high endemism and high biodiversity, really important environmental region, and with great cultural values as well. I'll talk about the difference between uplands and lowlands through the talk, and that really just is a concern between the plateau, the sandstone plateau in this environment, and the lowlands, the low forests and woodlands. They're sort of the two major habitat types. Okay, so you've heard the term fire regime, you know what a fire regime is. And we're going to start thinking about, okay, long-term impacts of fire regimes over time. So here is a quick glance at the fire regime for those project areas. You've got Kakadu, WALFA to the right, and you can see a little one down the bottom there. And you can see that over time, the fire regime has changed. You can see that in an unmanaged situation, you've got this sort of savanna boom and bust sort of cycle that happens without management. You know, fuel load accumulation, and a bust where you've got extensive hot fires, you know, and then it starts again, fuel load accumulation, extensive hot fires. And the result of that is that you've got a predominance of extensive hot fires, which are damaging. And with the onset of fire management, about halfway along there, you can see, or 2/3 of the way along, fire management, still seeping fires, little sort of light brown areas. That mitigates the extensive late fires. So you can see that change in the fire regime. Put that a bit more simply, and see this is the time series of these two major projects, Kakadu and WALFA. WALFA started, while it was registered as a federal savanna burning project, 2015, it actually began management with offset generated resourcing in about 2005, 2006. And so you can see there quite clearly the unmanaged fire regime, resourcing for management, and you can quite clearly see how, particularly the red line there, that's a 5-year average of late season fires, hot season fires. You can see how that's reduced with time. Unburnt area and early season, cool season fires in the orange. Kakadu is a similar story, although it started as a savanna burning project a bit later in the piece. So to take one step ahead, we've got this idea of fire regime thresholds of concern. And a threshold of concern is just defined as a point where an environmental driver changes such that it starts to have a negative impact on the environment. So the driver here is, of course, fire. And we can start to take stock of, past research, ecological field research, and look at how different aspects of the fire regime negatively impacts the environment. So here we've got a list of a couple of sort of basic metrics we can look at. Severe fire and woodlands. The woodlands in North Australia harbour quite a few obligate seeding trees, which need a long time between severe fires to reproduce. We've got metric there for biodiversity in woodlands, and this one's about sort of fire intervals that allow fruiting trees to come up into the environment and allow those resources for the particularly animals to persist, being fruit trees and structure for shelter, etc. There's one there for extensive fire and flora and fauna, and this is sort of geared towards animals that don't have huge home ranges that need somewhere to hide. They don't want the whole place burnt down in one go all the time. And likewise, we've got many plants that don't disperse very far. They sort of stay put, and they likewise need patchy fires to persist. The monsoon, the Arnhem Plateau is also home to some endemic monsoon forests, Carpia, and modelling has shown that those forests can start to decline if they have too frequent severe fires. So there's just one there about, if they don't get 5 years between severe fires, you can start to see declines in that habitat. Another sensitive environment up there is the sandstone heath, and that's also home to many obligate cedars. And that one there is geared towards that. So that says the heath wants to see, at least 5 years between any fire to allow its components to persist. So you can take these metrics and look at the fire regime and apply that to the mapping, the habitat mapping for the environment, and start to sort of infer how the fire regime is impacting on the environment or getting better. So if we go back to that fire regime sort of chart there with our 5-year averages, and you can see pretty clearly there how the fire regime sort of has trended over time relative to the project's beginning. And we start to look at some of these metrics. This one here is what uplands and lowlands seeing at least 10 years without severe fire. Severe fire here is defined as, hot season fires, late season fires. So here we've got, that's that WALFA, it's the top chart there. After the project begins, you can see a clear increase in the area that's meeting that metric. Likewise in Kakadu, with a bit more resourcing with the project start, you can start to see that sort of trending upwards as well. So this is the heterogeneity one. This is sort of looking at a combination between different fuel ages. so 3 years and 10 years without any fire. So this is talking about sort of building up, the landscape with different fuel ages, lots of heterogeneity in the fuels and the habitats there. That one's probably not so clearly increasing. I think in some, if you sort of talk to fire managers, you see that they talk about, looking for fuels to burn. They need to put fire in to mitigate fire, and often it might take 2 or 3 years to be able to make a fire break, So particularly that sort of younger fuel age is a tricky one to maintain. But I think particularly in WALFA there, you can see that the 10-year-old fuel is beginning to increase with time. 10-year-old fuel, 10-year-old habitat. What's this? 3 years since extensive fire. So this is talking about extensive fire. Plants and animals that don't disperse very far, have small home ranges, need patchy fires. In North Australia, we have big problems with feral animals. In the north, in particular, feral cats. And these things will travel for miles to a fire to go and hunt on the burnt country, because there's no shelter left for the small animals, So it's important to sort of maintain small patchy fires to try and help those components to persist. And you can see with management, with resourcing, with savanna burning, these metrics also sort of begin to climb up. It's quite turbulent now. You can see some big dips in these metrics, and they sort of relate to years where bad weather impacts the outcomes. You can have sort of, no matter what you do, you can still get some big fires every now and then. And of course, that's going to impact on things like extensive fire measurements. Last but not least, the monsoon forest and the sandstone heath. They're also increasing, as you can see there. But just to leave it at that, I suppose the takeaway thing is that with savanna burning and the extra resourcing, while it does go a long way to mitigating the impacts from broad-scale, extensive, severe fires, there's still work to be done in sort of addressing more nuanced sort of targets and being more strategic to do that going forward. Thanks.